Hi, it's Jan Beta, and today I'm going to build another Amiga 2000, 3000, 4000 keyboard based on an open source project that uses a custom PCB and readily available parts for PC keyboards. And I have to admit, I forgot about this project for quite a while. Looking at the date that I got the parcel from Graham, the creator of this project, it was nearly exactly 2 years ago that he sent this. So I'm sorry, Graham. Thanks for sending this. Sorry for my messed up mental capacity the last couple of years, really. But today we're going to tackle this project. There's going to be a lot of soldering of components and nice music by Focus 10, who I want to thank again for providing all the music for free for me to use in these videos. His stuff is available on Bandcamp and all the major streaming platforms for music, so check out Focus 10 on there and give the music some well-deserved attention. In a recent video I made a new Amiga 2000 keyboard. This is an original Amiga 2000 keyboard from an A500 keyboard and the Checkmate keyboard enclosure. This obviously comes with the catch that you still need an original Amiga keyboard to make this happen, but there are ways to use all new components and still have a big box Amiga keyboard, as we're going to see. And I think there's some other projects that are similar, but we are going to build Graham's version, which is completely open source, available on GitHub, and uses parts from WASD, who can custom print keycaps and things like that and offer enclosures. You need a custom PCB for the keyboard, and the project uses an Arduino-based Teensy little microcontroller to convert the keyboard matrix signals to the Amiga format that the big box Amigas can interpret, and then it should work like any other Amiga keyboard, really. So let's take a look at what we got. So here are all the components that we're going to have to assemble to make this an Amiga keyboard. We have the purple custom PCB for the keyboard, and this actually takes mechanical switches. Graham provided these Gateron yellow switches, but you can also use other Gateron switches or original Cherish switches, which are compatible with this layout here. We are going to have to solder a lot of diodes. This is where the microcontroller goes. We are going to have a connector, which we're going to make out of this cable. And this is not a project that you can finish in an hour or two. Probably this is going to take longer because there's a lot of soldering involved, as you can probably tell by this. We have the keycaps, as I said, custom printed to have Amiga logos and things like that by WASD. And we have our microcontroller, which is a Teensy++ Arduino-based microcontroller board. We have our keyboard accessories. We have the components we need, diodes, little resistors, pin headers, that we're going to solder to this. And then we have the WASD enclosure for the keyboard. This is a wide version of that. These are off-the-shelf parts you can buy from WASD, I believe, actually aimed at making PC-compatible keyboards. But as we're going to see, this is going to be pretty close to an Amiga keyboard and is going to work as an Amiga keyboard, obviously, in the end. That's the whole purpose of this project. And the whole project is called the A2000 Serotina or Serotina. I'm not quite sure how to pronounce that correctly. This is version 1.5, created by G.R. Shaw, which is Graham Shaw, and B. Perryman, which I don't know what the B stands for, but thank you both for making this happen. And with thanks to Liv2 and Rob Taylor, both of whom I've been in touch with online, and they are both contributors to the retro computing scene on a big level. The GitHub for the Serotina project is going to be linked in the video description. You'll find everything you need to build your own and which components you need. And there's a very nice walkthrough about how to make this whole project work. Yeah, I'm just going to go through all the steps and assemble this and play some nice music and some montages of me soldering and tinkering. And then we're going to test this in the end. And hopefully we're going to have a nice Amiga keyboard with mechanical switches. Or in this case, these are actually linear switches, but you can use mechanical clicky switches. Every variant of these should work in this keyboard PCB without any issues. I'm going to get my laptop and read through the instructions. If you want to make your own Serotina keyboard, you are going to need somebody who makes a circuit board from the files provided in the GitHub. And I can recommend the sponsor for this video, PCBWay, my favorite manufacturer for prototype PCBs of all kinds. They also do CNC machining, 3D printing, sheet metal fabrication, basically everything you need for your projects. I highly recommend checking out the link in the video description. Back to the Serotina keyboard. So here's the GitHub page. Sorry about the reflection there. We have the bill of materials with links to everything you actually need, including the keys, the keycaps, the enclosure, which is from WASD. We are going to use a 5-pin DIN cable, just cutting it in half to prevent soldering on DIN connectors. You can, of course, make your own cable with a 5-pin DIN soldered to one end. This is just a regular MAS50 DIN connector, round 5-pin DIN connector. There's crimping tools involved, which I'm going to link in the description, and the rest of the links are from here. Graham is located in the United Kingdom, so all the links here are UK links, but you should be able to find the parts you need for the keyboard elsewhere as well. These are all standard parts. And the electronics parts are just 150 ohms resistors and one N4148 diodes, 105 of them actually, so there's going to be a lot of fun soldering a Teensy, as I said, which is an Arduino development board. And we have red LEDs. You can of course also use other colors if you like, and we have a right angle pin header for the keyboard. So let's look at the build instructions, and I'm going to just follow those closely. First step involves drilling the keyboard case, which I'm not going to do. I'm actually going to use a file because my reputation with power tools is somewhat jaded. So we are going to make an Amiga keyboard, and this is a case obviously for PC keyboards, so it has a USB hole here that we're going to have to widen to fit this cable. This is a really long cable, so we're going to have plenty of room to place our Amiga. So this is roughly half of the cable. I'm just going to cut it. So in theory you could use the other end to make another Amiga 2000 keyboard. This is a 5-stranded wire, just going through from one DIN connector to the other DIN connector. So we're going to use the connections from one of these ends, halves, to make our Amiga keyboard connection on the PCB. Okay, step 1, widen this hole to fit the cable. And this cable insert here actually fits the cable already, so we don't have to do any modifications on that. We just have to file this out a bit. And this shouldn't take much actually, because there is already quite the large opening there. Let's see. Yay! It easily fits through the hole now. Now we're going to feed the cable through the hole into the case. And the instructions say we need 20 centimeters on the inside, roughly. So something like this. Next step is to remove the insulation from this cable. For 2 centimeters or 3 maybe. I'm just going to use my Swiss Army knife here to remove it. And this has a ground or shielding wire and some foil here for shielding. 4 wires and 1 shield. So 5 connectors in here. And the foil insulation we can just cut off. We're not going to need that. And then we're going to put some heat shrink tubing over our exposed wire, the shielding. And then we're going to crimp on a 6-pin DuPont plug. This is just a pin header plug, 2.54mm pin header connector with my crimping tools that I'm also going to link in the video description again. That should be the pin out for this particular cable. If you use another cable, of course, your color coding might vary a bit. And I'm also going to slide on another piece of heat shrink here to stabilize the connector. And of course we have to strip the wires. So I got all my little connectors crimped on there. Now they go into this. And we want green to be pin 1. VCC should be pin 2. That is pin 4. Yeah, that should be our connector. I'm going to heat shrink the cables a bit to keep it more stable. And then we're going to go on to the next step. Okay, looking good. This is our connection to the board. This is our connection to the Amiga. And now there's going to be lots of soldering. And we should start with the diodes, which are in here somewhere, I'm pretty sure. And you want to make sure that the polarity for all these diodes is correct. These components have a little black ring here, and there's a little stripe on the circuit board to show you where that goes. So these go in this direction here, and yeah, all the D designators are the diodes. So there's one diode for each key, and it's 105 separate keys. So all the diodes have to go in there. So I'm going to use my little straightening tool here to make this nice. These are pretty handy if you do something like this, just making sure each and every diode is in here in the correct orientation. I'm going to do a bunch at a time, I think, because this is going to take forever otherwise. This is going to take forever anyway. Oh, so yeah, I have my little air filter here, and I'm just going to populate everything and solder everything in place. Okay, I think I have them all in, all the diodes. And I also think that I put all of them in the correct orientation. That required quite a bit of patience. I actually find repetitive soldering like this kind of like meditation. or guru meditation maybe in this case. We need to populate the resistors next, which are here, here, and over here. These don't have a polarity, so you can put them in whichever way you want. It's always good style to put them in the same orientation for the color codes to be visible nicely, but it doesn't matter electrically. Okay, looks pretty neat to me. On to the next step. Now for the pin header, which is going to go on the underside of the PCB here. This is a 6-pin angled pin header. So I'm just holding this down flat on the PCB from the other side here. And I'm just tacking the left pin and the rightmost pin with a bit of solder and checking this is straight. Looks straight to me. So let's solder it in fully. Yeah, that looks pretty neat. And we want to snip the third pin off because that's going to be our indicator for the direction the header goes on here. Next up is our Teensy microcontroller. We only need to connect pin headers to these 40 pins on the sides here. Program this and then solder it to the board. And we want to cut strips of 20 pins from this. And we're going to sit it down in the board to get the positioning of the pins correct. So now the guide tells us to flash the firmware onto the Teensy. And we need the correct file. There's 3 variants, one for PC connected via USB. So you can easily use this in a PC if you connect a USB cable. And there's one for the A2000 US and UK keyboard layouts, which we are going to build here. And then there's another firmware for the international keyboards. We need the Teensy loader software, which is available from the Teensy website. And I already have this installed on this system here, and we need a mini USB cable. So let's download the Amiga US UK firmware, which is a hex file, and we should be able to program that on our Teensy without much hassle, just connecting it via USB and using the Teensy loader software. We are going to start our Teensy software here. Press button on Teensy to manually enter program mode. Pressing the button. Okay, file, open hex file. And we're just using our hex file here. Programming it. Download complete. We can reboot the Teensy. Reboot OK. And it already says that it's a keyboard. But we don't want to use this on this MacBook here. The MacBook recognizes this as a keyboard already. We can solder this to our keyboard PCB, it says. And goes in here like so, with the USB port facing outwards, so to this hole here. Basically the same procedure as from the other side. I'm going to tack some solder on the outer pins here to hold it in place. And then we're going to solder all the pins. Now for the LEDs. We have quite a few red LEDs here. And for these we have one longer leg and one shorter leg. The longer leg is the anode, that's the positive side, and that goes into the round holes on the circuit board. Now this has room for quite a few LEDs actually. These here are just status LEDs for debugging and things like that. I'm not sure if I want to populate these. We have a separate caps lock LED that is going to go through the little hole in the keyboard enclosure that says caps lock. That's going to be populated. And then we have LEDs for the keyboard reset, Amiga Control. And we have a proper caps lock keyboard LED for the caps lock key that is going to light up when the caps lock is activated, just like on a regular Amiga, only that the LED is separate from the key and not inside the key. You can leave these reset control Amiga LEDs off here if you want. I think I'm just going to populate the caps lock LED, although it might be fun to have the other LEDs as well. Decisions, let's see. I think I just want to populate all of these LED positions just to see how that looks. So I'm going to leave these status LEDs unpopulated, but I populated all the other ones for the reset and the caps lock and the caps lock indicator on the keyboard enclosure. It's the next morning in the lab and I slept over it and had another look at the instructions to build this, and I realized I made a bit of a mistake. And the mistake was that I soldered these LEDs that go inside the keys onto the circuit board before I put the key switches in. These LEDs actually go into the switches, so we have to put the switch in and then stick the LED in there from the top. But that's no big deal. I'm just going to use my desoldering gun and get rid of these and put new ones into the switches after the fact. At this point, this is a functional keyboard. We just don't have any switches, but we can still test it, which I'm going to do. That's a good idea, I think, at this stage, by just shorting out the contacts for the switches. And also the LEDs are going to light up, I think, which is going to be nice for testing purposes. So I fired up the Amiga test kit and I planned to short out the contacts with this pair of tweezers here, but we don't get any action, so not sure what that's about. We also don't get any of the LEDs to light up, so maybe something is fundamentally wrong with our cable or with our circuit board that we built, which is pretty bad. So let's check the voltage supply to the little Teensy board. We should have 5 volts on this pin here and ground on this pin. That's negative 1.1 volts. We put something wrong in the connector probably. So I'm just going to double check the cable in continuity testing mode here. Oh, I think this is the wrong polarity basically. The white wire is ground. Is that correct? I don't think so. There might be a mistake in the pinout there. Yeah, that's actually wrong in the pinout here. Pin 4, which is white here, +5, should be ground. And pin 5, which is ground here, should be +5. According to my notes here, that is not so great. So maybe this is all reversed. This is reversed. Let's double check that again on the connector. Yeah, that's exactly what this is. This wiring is off. This is pin 1 on here, and that should be connected to ground, which is our green wire, and that isn't connected to ground. That's exactly mirrored. Yeah, so we have to swap some wires around, I guess. So this should be the correct pin out, looking at the plug from this side. So we have the whole thing mirrored. The only thing that's correct is the data, which is the center pin. So we have our 5 volts on pin 4 and our ground on pin 5. And we have our clock on pin 3 probably. Okay, I'm double checking this and then switching the pins around. I think that's actually wrong in the instructions. And of course I should really have double checked that before powering this on. So we're going to rearrange everything a bit and swap the pins in the crimped connector, I think. And then double and triple check the pin out, I guess. Just have to wrap my head around this. This should be ground and this should be connected here, which it is. So this should be pin 1, the white, which is ground, which it now is. Okay, this should be +5. This should be on pin 3. And the last one stays here. Whew. Okay, so this should now be the correct wiring. You should always double check your wiring. Let's see what that gives us. Okay, wires reversed. Let's try again. Ah, and now we get this light to light up. So the pinout on the website is incorrect. Let's see if we can start stuff up here. Yup, now it works. I'm just shorting out the contacts here. Just checking all the keys here. Yeah, and these actually light up now, which is also nice. Not sure if I want that behavior. Let's see if the caps lock lights up and that stays on and the other LED also comes on. And if I hit it again, it should come off. Yay, it works now. We just had the wiring wrong. And now we can continue working on this and get the Amiga 2000 out of the way and see if we can add the keycaps and remove the LEDs. I should obviously have checked the pinout previously, but I didn't because I was so sure I could just follow the instructions. Always double check. So the next step is going to be removing the LEDs I wrongly put there, and then we're going to fit the switches in the next step. Yeah, this is just going to be desoldering these with my desoldering gun. And yeah, fortunately the Teensy didn't break. I was a bit worried about that. Seems to be pretty resilient. Now for the actual switches. We have to modify these slightly. I already did that on this one. They have some mounting lugs here, just little plastic lugs that we have to cut. This one and this one. The center one is necessary to keep it in position, and we have the two switching contacts here basically. So we have to cut this and this. I'm just going to use my flush cutters for that, for each individual key. And then it looks like this and can be mounted flush on the keyboard PCB. These lugs are not there for all switch types, just for the PCB mount variety of these. So we need to remove them from here. We are now going to use this metal plate here, because the switches are going to be soldered over this. This actually keeps the switches in place. And I'm just going to put the one we already did in here, basically. These clip into this metal part, which is also part of the keyboard case, I think. So we need to put some in the corners here to align this, and then we can solder these in and then put the rest of the keys in. And then the contacts go into the contact holes here. And these plug into the metal bezel like so. And I'm going to clip these into the metal and then solder the contacts on these to position the bezel correctly. These should be clipped in quite nicely now. We are just going to solder these in, I guess. Yeah, looking good. And now this whole construction is stable. So the bezel is connected to the PCB with the switchers. And I suppose we're just going to solder the rest, going in from the corners here. So yeah, we're going to place all the other switches now with the little lugs removed and solder them in. And for the caps lock LED, we're going to put an LED into the switch. Actually, there's a little cutout on these to put the LED in. That should line up with the holes in the PCB here. And here goes another montage. These actually click into place, which is nice. You have some haptical feedback. All the key switches are in place. That took some time and some patience, but yeah, I'm pretty happy with the result. I just need to clean the backside of the PCB thoroughly. And I also spread 200 of these little plastic nubbins all over the lab. So it's going to be a good opportunity to clean the lab, which is due anyway. So now is the time to put in the LEDs into the switches. There's actually a cutout in these switches where the LED goes, and I want to solder the caps lock in here. And the longer leg goes through the round hole. This should totally fit like so. Yeah, there we go. That's how you insert these. And you can do the other keys that have LEDs, but you don't need to. And I'm just going to keep it kind of original. So no flashing LEDs for the reset keys. But yeah, that should be all the soldering we need to do, which is a lot. Okay, this feels really sturdy now. And I guess it's time to plug this in and give it a proper test with all the switches in place here. And we should have all the keys light up in green here. We have some keys here that won't light up because they are not assigned to anything. Because the count is for a PC keyboard actually, so we have more keys on this keyboard than the Amiga has. But that looks to me as if our keyboard is fully functional. So we're going to finish it by putting the keycaps on and closing the case up and things like that. So I'm just going to add a cable tie to where the cable gets into the keyboard here, just so it doesn't slip out of this case. Locked in place, nice. Yeah, now we have to attach the stabilizers for the keys that require a metal retaining clip, stabilizer clips. We have a lot of those. So these are the metal parts that go into the keys. Okay, let's see. These are the ones for the keyboard, and I think they just go in like this. So we have one end where the metal bar clips in. These just clip in here. Yeah, that's how it goes, I think. And of course we have other switches that also need these metal retaining clips here. We can also fit the screw for the keyboard, probably that there's one screw holding the whole thing in that we should fit at this point, I guess. That is just the larger black screw that is included in the kit here. And that goes here. That just holds this in place. Putting the rest of the clips in here. And these are all the same, it seems. That's something. Oh, now for these, the metal parts. And these parts go into the keys, the keycaps. So the keys come in this nice pack here with a keycap puller. And we have individual bags here and a sticker. These came from WASD, same as the case. And these should be custom printed with Amiga logos and things like that. So looking forward to that. We're going to be assembling the keys that need one of these metal bars here first. I think that's these. Ooh. Red Amiga logos modeled after the first Amiga keyboard. Yeah, we're going to have to put these plastic parts into the keys actually. These should be facing towards the top of the keyboard with the longer part of these. This is how these are shaped. This part goes into the key and this holds the metal bar. So we're going to put these in here like so, towards the top of the keyboard. Let's see if that works. Start with the space bar. Oh, these clip in nicely. So this should now fit our metal rod here. And we should be able to put it on our key switch. Okay. Yeah, that seems to work. Okay, so this is the way. For the horizontal ones, you want the longer part of this clip that goes into the keys facing upwards. And for the vertical ones, you want it facing left. It's a bit sticky, but I guess it's going to work itself in a bit. And you could add some lubricant to this, obviously, which the pro gamers are doing, I think. But it works quite nicely as it is. Yeah, so let's do the other ones. Put on the top case! Yay! That is the literal next step. We have to do some modification to the top case. So this is the top case, and as you can see there are kind of light guides for the LEDs that you normally fit in this corner here for scroll lock, caps lock and num lock, I think, for PC keyboards. And we have to cut these down because otherwise our Teensy won't fit. But we have to leave this one for the caps lock because we're using that actually. This is relatively soft plastic, so this shouldn't be much of an issue. And you can just nibble them off with your side cutters. There we go. That should be enough room. So we have 3 posts here that this goes into. This is just a very standard PC thing. So we have to guide these in here. And then this clips on basically. This is a very sturdy construction, even if it's not screwed in yet. Pretty convincing. Put the feet on the bottom. We have some feet. So these are just going into these here. So these go on here. The rubber feet. So now we put the screws in, which are 3 silver screws. So 3 screw holes here. Yeah. Solid. Okay, now we put the clips in, or the little standoff thingies here. To just go in here, I suppose. Yep. Ooh, nice. Okay, this is a really nice keyboard. It's better than any Amiga keyboard I've typed on. Looks good. It looks good, even without the keycaps. With the keycaps, it's going to look even better. And I think that's the next step. Yay! So, cue another montage of putting the keycaps on. We're going to go by this photo on the GitHub, and we're going to put each keycap in the correct position, hopefully. This should just be pushing these down on the keys. I found the escape key. And this doesn't look too far off from an actual Amiga keyboard, which is pretty nice. And I think the little bags here are sorted by the row of keys. Okay. And there are quite a few blank keys in here because, as I said, the PC has more keys. But you could put some functions on these, I think, in the software. So yeah, I'm just going to go through this row by row and try to assemble this. Ta-da! Looks pretty cool and beautiful. And the red Amiga keys are such a nice touch. So yeah, this is a super nice new Amiga keyboard for your big box Amigas. And it's also fun to assemble. You just need to allocate some time for that. That took me like 2 days now. It feels really nice. It feels way better than any Amiga keyboard, really. And if you get the clicky switches, those are going to be nice as well. These yellow switches actually feel kind of similar to what the original Amiga keyboards feel like. So that was probably the intention. But as we've seen, you can use pretty much any Cherry MX compatible switch, or even Alps switches, I think. The PCB has holes for the contacts for Alps switches as well, which were also used in the Space Invaders Amiga keyboards. So in the end, this is a nice mix of traditional Amiga and a new PC-style keyboard. And hey, it does fully work. This is kind of a workaround keyboard layout-wise, but I think it works quite well. Amiga Control is going to be this instead of this, because that's going to be a bit of a change. But otherwise, it looks pretty much super nice as an Amiga keyboard. I mean, it doesn't quite fit with the quite yellowed Amiga 2000, but if you have this separately on your desk, it's going to look nice. I'm going to show you what the caps lock key looks like. So not really too easy to fit this on my desk, but you can see the LED shining through the caps lock key. And that looks pretty cool, I think, actually. The original Amiga has a little window there. And of course our caps lock LED here lights up as well. We don't get any spill into the other LED holes there. Could put a sticker here, even covering these holes, I guess, like an Amiga sticker. I'm probably going to end up doing that. Let's see if the reset works. Yeah. That behaves like an Amiga reset. Nice! So we made a really cool new, all DIY, all open source, except for the keyboard enclosure and the keys basically, but you can order these and have them printed to your liking from WASD. Yeah, this works really well, looks super nice, and it was fun to build, as I said, repeatedly now. Yeah, I think that's it for today. I just wanted to show you this beautiful new method of making an Amiga keyboard with a little Teensy in there. Pretty much a PC keyboard with standard PC parts with changed firmware and another connector connected to it. Works really well, looks nice. This is a nice alternative if you want to build something yourself and you don't have a keyboard for your big box Amigas. So that's it for today. Thank you very much for your time. Hope you enjoyed this video. Thank you so much for your support on Patreon and on Ko-fi and on the YouTube channel memberships page and elsewhere. If you consider giving me some support to make these videos happen in the future, please take a look in the video description. Scroll all the way down and you find some links there with Patreon and Ko-fi and things like that to support me. Thanks for watching. I'm Jan Beta. See you next time. Bye.